Welcome back, folks. Today we're trying something a little bit different than our usual vlogs, and we're going to show you how we built every single carbon fiber panel for the Miata, starting from 3D modeling in Autodesk Fusion all the way to making the carbon parts. We're going to break into a two-part series. So the first one, we're going to cover modeling in Fusion, a little bit of how we do 3D scanning, just briefly touch on CFD and show how we prepare the parts to be printed. And then later on, we're going to cover how we go from the prints to the molds to the carbon fiber parts. So let's jump right into it and let's open Fusion. Okay, so you decided you want to build some body panels for your car. The first thing you're going to have to decide is which CAD software to use. Obviously, there's many options out there. These here open is Autodesk Fusion. Personally, I think it's a great choice because it's free and it has a range of tools that makes it easy to model like more geometric parts like brackets and things like that, but also has the form tools, it's called, which allows you to easily model more organic shapes like a car body. Today, I'm lucky enough to be part of their creator program, so I have access to a few more tools. But everything that we're going to show here, it's available in the free version, so you can just download it and give it a try. So you can see here that I kind of already prepared a file for us that's going to show what we need and make it easier to show what we're going to model. So the first thing that you need is some reference, right? So we're modeling a body panel that's going to fit on a car, so we need something to make sure that that's going to fit on the car itself. One option is to go out there and 3D scan the car yourself, but if you don't have a 3D scanner, you might also be able to find a model for a car online. Sometimes they're paid. This time I was lucky enough to find a model available for free on GrabCAD. So if you do some Googling, you might be able to find a model for a car as well. So this is what I started with. So just like the real car, I deleted everything that I didn't need. So there isn't that much left, but this is all, today we're going to model a rear fender for context. So that's really all we need. It's actually more than we need. But yes, the other option is you go out there and 3D model yourself. We use a relatively budget scanner. It's called an iStar. It's honestly a great option if you're like us getting started and you don't have a big budget. So you can still get very good scans, and it's a relatively affordable tool, and it's a great tool to have. So we can see here I went out there and I scanned the actual car, and we can validate against the model, see if everything fits. So here, for instance, I needed the cage to make sure that the fastback would fit when I modeled it, and that's when a generic 3D model that you found online wouldn't be good enough. The cage in my car was custom built, so I needed the actual scan for my actual cage to make sure that that would fit. So here you can see like there's a little bit more in there than just the cage. It has the engine, it has the hood, and you can see that kind of lines up with the original scan, even though there isn't that much left of the car. But for today, for this exercise, we're actually just going to work with the model that I found online. We're going to be working the rear fender, so we don't really need the cage or these other details. This scan was also a little bit too heavy. That's something to keep in mind. If you're scanning yourself, you might want to, turn down the resolution if you don't really need that much, because it makes it more difficult to work in Fusion. Let's hide that scan and let's just go back to just the model that I found online. And as a reference, I have some of the stuff that I had already modeled here, and you can see that this is the quarter panel that we're going to be working on. Full disclosure, this isn't going to be a full comprehensive tutorial on how to do form modeling in Fusion. There's already great videos about that on YouTube, and I'm happy to link some of them below. That's how I learned it, and I can share the videos that I found particularly useful. This is more of a overview of the end-to-end process with some tips and tricks for every step of the way. And then we can obviously add more and more resources for each of the steps. So yes, this is the fender. We're gonna go and create, just give you kind of a starting point and some tips and tricks. So let's say we don't hide this for now, and we want to start a new version of the fender. So what we need to do is we need to go up here and use the form tool, and we need to click create form. But you're going to see what happens when we do that is the other fender just kind of vanishes. And that can be tricky if you're trying to, let's say we're making another fender, we're making the fastback, and we wanted it to line perfectly with the fender. So that would be quite tricky, because even though we have kind of a shadow of it, it's very hard to see it properly. One trick for that is I'll just undo it, the new form. Here we're working with the timeline mode in Fusion, which you can see every step here. If you haven't used it before, this is a great tool, especially if you're doing sketches. So let's say you model a plate and you make all the holes in that plate 6 millimeters. Then you go to the car and you realize that you actually need 8 millimeters holes, because, you know, whatever you're bolting to the car needs 8 millimeter bolts. So you can kind of roll back, edit your sketch, and it automatically reapplies everything else. So if you build other things based on that original sketch, things will just be updated to the new sizes. So that's awesome. But when you're working with forms, it's not always an advantage. So personally, I find it easier to right click on the name of the project and then just click do not capture design history. It's going to tell you that you're going to delete, you're going to lose your history, which is okay. So sometimes I'll have multiple files where I can kind of move things back and forth. So in one I have the design history, the other one I don't. So for this case, let's just delete it. And now you're going to see that we no longer have the create form button, but instead we just have the form tab, which allows us to use the form tools directly, you know, from the top level context. And here we can decide, you know, how we want to get started in our fender. And this one is, you know, obviously still visible. An easy way to start is with a cylinder. So we can just go here and right click on the panel we want it to be, and then we just kind of make a circle. The size here doesn't really matter for now, and you can see that's created this cylinder. Oh wait, so right now I have the edges hidden, which is Ctrl 4. If you want to make them visible again, you just press Ctrl 6. So that helps. So we can see that now we have 4 divisions in that direction. So we can just go here, make just 1, and we keep 8 in the other direction, which is fine. We can change the height, it doesn't really matter here. We can make like 100 or something like that. The diameter might be easier to start with the diameter of our tires plus some margin. So the tires that we're running is a 650 diameter. It's a 280 by 650 slick. So we can make these, if we add, let's say like 1 inch, that's 25 mil in each direction. So the diameter is not going to be 700. So we can just make that. Cool. So here we can go, if we want to work with forms, then we need to use the edit form button. So now we can just select it. If you double click on a face, you select that whole body, which is useful when you just want to drag things around. And I also find it easier to work with the planar face. So if you just click right there, and then you can drag it here, and it should be fairly close to the size that we already have. And then we can also look from the top and just move it back here. One trick that I think is also helpful is to be very clear, like usually move when you're looking, you know, straight down or side, and then try and move it one direction at a time. You can also move 2, but depending on what you're doing, it might be easier to do 1 by 1. And Fusion will also move in steps, so you can just edit the number by hand until you're close enough to what you want. So here we are 780, that's close enough. Let's see. Yeah, we didn't quite nail the position of the radius, so we can just, it's still selected, so we can just click edit form again, and here again it makes more sense to move in 2 planes, right? So here we'll be moving in Y and Z. So obviously we're not going to recreate the full fender, so it doesn't really matter. We can just put it in a place that looks close enough, and we can also see that the fender actually isn't fully round. The reason for that is when you have multiple panels, Fusion kind of pull things around. We're going to look a little bit more in a second, but yeah, it's one of the small challenges that you're going to have to learn to deal with. But these are very small deviations, and it's not going to be noticeable with the full car. So yeah, now you can see that also this obviously is a circle, right? It's like perfectly round. And that's like what in Fusion, in the form tools, it's called a smooth display. We can also change it to box display. So you can press Ctrl+1 to go to box display, or you can go under utilities, display mode. And then here you can see this is box display, and then you have control frame, and then finally you have the smooth display, which is what we were using before, or the shortcut is Ctrl+1, 2, and 3. So nice. Obviously our fenders are round. At some point they need to come straight down. So we can just go and delete some of these faces. So we can delete these one and these one. And yeah, let's delete these one too. Ooh. Here there's a couple ways to deal with that one. We can either delete it or we can leave it here and then just move those vertices. Yeah, so we can move these one. Another nice trick is you can move your anchor point. So you can, or your pivot, I guess. You can just go and you can move to that edge there, or that vertex, and you press down, so that's where you want it. And then you can just change in this direction, and then you can set it to 0. You can scale to 0, so it's going to be perfectly vertical. Another way to do that is you can just, if we do on the other side in a different way, you have to be careful because here we're selecting vertices. So if we just click, and if you had just clicked here and then you look from the side, you're going to see that we selected only one. So if we start moving that up and down, we're just distorting it. So let's undo that. And then the easiest way to deal with that is if you just box select it. Now we selected the whole edge and we can extrude it. So to extrude, if you want to, just extend that down, not just move that point, you just hold Option on Mac. I think it's Alt on Windows. I'm not a Windows person, and just drag it straight down. So now you can see that what we did is we created a new face there. And we can go back to Smooth Display and see what it looks like after our changes. So this is where things get a little bit tricky and why my fender isn't perfectly round. You can see that even though this is perfectly vertical, it's not exactly where we want. So we can just move, like box select, and move it back just a little bit. So again, like moving too big of a step, we can change it to 30. And when I'm doing these kind of big movements, I'll go back and forth between smooth display and box display, so I can see what it's going to look like. So here, like we can see that it kind of brought that corner in too far. So we can just go here and drag it down a little bit. I usually just go back to box display and try and move only in one direction. Yeah, so you see that you're not going too far from the shape you want. So these looks not great, but good enough for, for demo purposes. We can do the same thing on the other side. Just drag it here. Let's say just 30. That should be good enough. And then, yeah, this edge here. Selected nothing. Just drag it up a little bit. Cool. Again, not perfect by any means, but it is good enough to just show the process. So we press enter. I'll hide the original fender now. I feel like we've used it for what we needed. If you press V for visible, you can just toggle things on and off. And you can kind of see how much we're gonna have to cut off the original fender, and that's before like the tire even moved. But cool. So now what do we do next? This is just the sort of like arch. So it's not even the liner, but it's kind of similar to the liner. But if we want to actually move into making the fender, we need to extend the outside. So we're making, the outside skin. An easy way to start with that is if you just select that whole edge loop, and then you hold Option again for extruding, or you can do Command and Option. I guess on Windows is maybe Control and Alt, and then you use the scale, the planar scale, and then basically what you're doing is like you're just creating a face outward. Of course, you're going to have to adjust those edges. They kind of just went further down. But yeah, it gives us a decent starting point, and we can also see again like in box display. Maybe that's a bit too much, so we can just bring it back down a little. So let's say that this is decent, and let's go from here. And now we'll have to do that again, but this time I'm gonna not I'm not gonna use command, so I'm not gonna crease the edge. So when you crease, you get a hard line. When you don't crease, then when you go to smooth display, that's gonna be a soft line. So here you can see like how this was creased, so it's a sharp 90 degrees. But now if we move this edge, we kind of get this rounded look. So this kind of looks a little bit like a fender flare. So maybe that's actually a better idea, you know, just make it look a little bit more like a fender flare for the purpose of this video, instead of trying and making the entire fender. So yeah, let's keep going. So here we can select these two edges, and again we can change the pivot to here, and we say down, and then we can scale horizontally to that point to 0, and now we get a straight line, and we can repeat that on the other side. Cool. So now, you know, this is a bit of a, it's just done by eye. There's no way, because this is a mesh, like when you scan you get a mesh. This is a sort of a native object, of, if you will. I forgot the actual name of the representation. I should have mentioned that at the beginning. I'm not an engineer. I don't work with this for a living. I'm not a CAD engineer. I just started learning on my own time because I wanted to modify my car. But it's worth for me. I feel might as well share some tips with you guys if you're just getting started. Now, if you want to just make these fit right, you just have to kind of like do it by eye. As I mentioned, like, this is a mesh, so you can't use one to like subtract from the other or just say like cut it there. So you kind of have to drag it and just visually make sure that it's as close as you can get to the body. So you kind of just drag it and see what's looking like. Usually you start with a very coarse form, so like as little edges as you can. That's easier to manage, and then as you move along you can kind of add more refinement. So obviously to match the curvature of the car, you're not going to be able to do it with just these small amount of vertices. You're going to have to add like more here, so you can kind of pull it in. I can kind of demo that quickly. First, like, we'll have to go edge by edge and make sure that it's as close to the surface as possible. Now, usually I would do that once I'm happy with the overall shape. I'm just cutting a little bit of a corner here, and usually you're going to want to do that in smooth display, so you kind of see what the final piece is going to look like. So this is close enough. You can see like how the lines are fairly close, and then you do it on the other vertex here. Yeah, so you select that, and then you can drag it until you just see it poking out like that. Now you're gonna see a problem, right? Like in the middle here, it's inside the body, but both of those points are already sticking out a little bit. So how do we fix that? And that's where you need to start refining your form. That's usually like towards the end, as I mentioned. Like you don't want to have too many vertices or too many edges, too much geometry to work with at the beginning. So here we have to go to modify, and there's a few ways to do it, but in this case I think this is going to insert edge here, and then you can double click an edge to select the entire edge loop, and here you can give it a value, which is a distance. It's a fraction of the distance between the edge and the next one where it's going to be inserted. So you can change between positive and negative values to decide which direction you go. And here you can see that towards the side, towards the other edge, it's all like we can see the whole edge here. And here it's like very close to this vertex, it already vanishes. So it might be better to keep this edge closer to this one. And that's going to impose some challenges that we're going to see very soon. So let's say we press enter. Now you can see it completely changed the shape. And that's just how forms work in Fusion. it kind of like big panels kind of pull on the other ones, and if you have edges too far from each other, those can be deformed more easily. When you have edges very close to each other, they tend to pull the form. So there's a few ways to deal with it. Like you can add more edges all around, or you can just, like in this case, we need these two vertices to be close to each other, but these two don't really need to be close to each other. So you could just select these one and move it. So we can go here, edit form, and move it around. For some reason I can't click there, but and here you can just, you know, for now I'll just kind of have a look at it and make it kind of look around. This is closer than before, it's not great, but it's a little bit better. And then we can do the same thing, like again, move back and forth between box display and smooth display, so you can kind of see what you're doing. And similar here, this is a bit of a weird shape, and that's where, you know, you kind of have to go back and forth and see what works. You might have to move these edges as well, but I don't want this to be a 10-hour long video, so I'm just going to stop here and I'm going to show you the next step. So, you know, let's just pretend for a second we're happy with this shape, right? We can hide our mesh here, and we can just focus on these fender. So let's, yeah, pretend that this is good enough, even though I know it isn't. So we don't need these usually, so we can delete these. And the first thing that we're gonna need to do is to thicken it. So right now this is just a surface, so it has no thickness. It's not a volume, it's just a shape. So if you want to print it, we need to print something that has volume. So we need to go here and we need to go back to solid, create, and thicken. Here we'll select the form that we want to thicken. It also works with surfaces, and then we choose the direction. So here, let's say we want to make it 10mm thick, which is what we've been using lately, and you can kind of see here that's thickening inwards, and that's going to depend on what face do you want to be accurate. So if you're doing a positive mode, so if you're just laying the carbon outside, then that's going to be okay. Or if you're just skinning it and keeping the print, this is also going to be okay. That's what we did last time, and it works okay. It has some drawbacks, which we're going to cover in the next video. We're going to show you the before and after panels. But for now, what we started doing recently is we started creating, printing the negative force. So we're kind of printing the mode directly. So in that case, we want to, you know, extend outwards. Now this can take a second if it's a very complex shape, but yeah, and it can also fail sometimes. You have to kind of tweak the shape, especially like when it thickens, if one part overlaps with another, that's a problem. Yeah, we can kind of cover more about that, doing these with complex forms. If you want, just leave a comment and we can kind of go about that. Same with if you're doing vacuum infusion, or if you're, you know, doing any vacuum bagging. You may or may not want flanges. There's multiple ways to go about it, but if you want us to also cover how we go and we add the flanges to kind of glue the vacuum bag to around it, just same thing, leave us a comment and we can make another video that goes more in detail about, you know, the separate parts of the process. And we'll keep these one, you know, it's already quite long, but we want it to be more of an overview rather than a deep dive into each part. So yeah, just let us know what you want to hear more about and we'll get it done. So here, if we go to bodies, we still have the surface visible, and now we have the body itself. And, you know, again, let's pretend this is good enough. This is what I want to print it. Now you're gonna have a small problem, which is this part is very big. So if we just, you know, there's multiple ways to measure in Fusion. One way is just select 2 points, and then the measurement is going to show on the bottom right, but you're not going to be able to see it because I'm standing there. So the other option is just go to inspect, and then point 1 is already selected. We select point 2, and now we get the distance, which is 1.3 meters. And maybe some of you will have a printer that big, but my printer is only 256 cube. 256 millimeters. So we need to divide these into multiple parts. There's more than one way to do it. Of course, like anything else, you can just load into your slicer and cut it there. I find that a little bit difficult and time consuming. There's also a software that can do that automatically for you called Luban. We tried that in our latest print, but we haven't assembled it yet to be able to, actually say if I recommend it or not. But I've seen other people using it. But the way that we have been doing until, we just tried Luban for the first time is you kind of just go here, you make a sketch. It doesn't really matter the depth. So I draw a vertical line. Here, and make sure that you kind of cover the whole part. Doesn't really matter for the cutting itself, but it's easier to visualize what you're actually doing. And then I make a horizontal line so I can cut in the other direction. Nice. You can see that these constraint here means that it's fully horizontal or fully vertical, and that should be good enough. Then I kind of just drag it close by hand. It's not critical, like how close you are, but yeah, I just get as close as possible without actually going over the part. And then we can go here, we can create a rectangular pattern, is what it's called, and we can just use it to replicate this line in 2 directions. I prefer just select one at a time. So here, just this line, and then you can just drag it out. And here you can either choose extent or spacing. I find spacing easier, which means that when you change the distance here, it's the distance between each line. And these is gonna be roughly the size of your printers. So you might be tempted to put here, let's say a 256, since my printer is 256. But since it's a 3D part, it might be curved in ways that you didn't think about. It might end up not fitting, or sometimes it will fit, but just about, and then you can only print one piece at a time, which might not be what you want. Like we're going to talk about that a little bit later when you cover the 3D printing. And then here, just however many parts you need to cover the whole body. So let's say 10, or that's a bit wasteful. We can do 8 or 7. Let's say 7. Cool. Now I can do the same thing in the other direction. Just create a rectangular pattern. Select the other line. Same thing. Just drag it. I'm going to stick with 200. That worked well for us recently. And then however many you need. 5. Good enough. Cool. Now we're done with the sketch. We hit finish sketch. And then we're going to split body. You cannot split with intersections. With intersecting lines. So here we can't split with all of them at once, but we can split with all the lines in one direction. So here we can select 1, 2, 3. You don't need to hear me counting, I know how to count. Cool. And then you hit OK, and then that's done. You can see now that was cut by those lines, and now instead of 1 body we have 7. Now next up we need to select all of these bodies. You can either select here by clicking one by one, or you can also select here. So, and you shift select to select all of them. And of course I missed that one. Cool. And then we go and splitting tools, and we select all the lines in the other direction. So 1, 2, 3. And do we need 4? Nope. But doesn't really matter. And nice. So now we actually have decent sized parts that we can just send to our slicer and print. I'm going to show you real quick the actual fender that we're going to be printing for the car. Okay, so here's the actual quarter panel that we're going to be printing. You can see that I did some of the things that I mentioned, where I kind of added the flanges, and then I added like some nice chamfers so we can release the part and all that stuff. Again, like if you want to see how I did that stuff, just drop a comment and I can make another video about that. But now Reese has actually been managing our print farm, or little print farm down in Burgos. So I usually just send him this file, and then he takes over from here.
So after Zagallo has finished everything that he needs to in Fusion, he then shares the file over to me. Once I've got the file, I then start to basically disassemble the model into individual meshes that then go into Bamboo. So I'll show you the whole process of how I do that now. So now that we're inside Fusion, we first going to start off by creating a new component to work with. So the new component is basically just a new file system or new folder system inside of the Fusion project that you're working on. There's tons of videos of file structures and all that kind of stuff on YouTube, so if you need a little bit more education, go check out some of those. But for this component, I always just call it printed. From there, it'll always select the one that you've just gone into, so I need to make sure I select the main component once again. And then from here, I'll basically just go through, find the piece that I need to export, save as mesh. Good thing with Fusion is it has this preparation type print utility, and when you select the print utility, you can then select the application. So application for us is obviously Bamboo. You can use Cura, Preform, and then the custom one you can select pretty much whatever you want. This is always make sure you're exporting in STL and always in, well, up to you, but millimeter for us for the most part. From there, it's going to automatically open Bamboo. The piece will then import. We auto orientate where it needs to go. This is a bit of a slow process, but I tend to manually align wherever I want them to be on the build plate, just so I can fit as many as possible. And that's number one. Then we go back here, and I'll move piece one into the printed section, so I know that I've already exported it. You can see here that the color has changed. That's also a nice visual indicator that it's moved. If it's not like that, if it comes up as just sort of a single color, you can press Shift N and that'll basically separate it into the different component colors. After that, we move on to the next piece. Save as mesh. And that's it. The whole process from then on is just to go through each of these, line everything up the way you want. My tip is I'll put piece 1, piece 2, 3, 4, 5, etc. So once I then take it off the build plate, I can see quite clearly which one belongs to, or which number is each piece on the build plate. We then name all of the build plates to what pieces are on board, so I can see from the print name on the printer themselves. And after that, we're pretty much good to send it to the printer. So once you've gone through and exported everything from Fusion into Bamboo, this is basically what you'll be left with. We've been quite lucky. We found, because we're using Adenor filament, they actually have a preset profile on their website that you can download and use. So we've been using that. We've messed around a little bit with the temperature because that was a little bit off for us. So we wanted to try and match our print quality between the X1C and also the P1Ss. Basically, for us to try and save a little bit of time, our print settings are pretty much the standard Bamboo Lab ones, but we go down to 10% infill and also a gyroid infill pattern. For the most part, we will also try and add a brim, either 5 or 10 mil thick, just because these are very skinny pieces and very tall. We did have, unfortunately, a couple of failures during printing for them falling over, which is why we've now implemented the brim on the rest of the pieces. So now that we've finished all of this up, we can go ahead and slice the plate and send it over to whichever printer we like. So all of our printers are unfortunately busy right now, but when they're free, we can send it over. Next up, we head across to the print farm. So we've been very lucky. We've partnered with Adenor for this project. We've picked up 60 kilos of their Pecci Economy, all in white. As you can probably see, we've already been printing for about a week now. So we've got 70 something pieces here, which is the front clip, and we've also finished up printing the fender. So that's what we're going to continue with right now. Printer 2 is just finished up, but we're going to load up a fresh roll of filament into printer 3, and that's the machine we're going to kick off the next print in. So the great thing with the Bamboo Labs is we also have the handy up, so I can see that printer 2 is finished up, I get a notification, and then I can also see that this is piece number 63. So from there, we remove. And then we use my imaginary.
Let me throw it on the ground because fuck it.
Stress testing. On to the next print. This was the last piece we needed for the rear quarter panel. So now we just do a little bit of cleanup from the brims. And now it's time for assembly.
So now that we've printed every part, all of them have a number that matches our CAD design here in Fusion. So we just go through each one of them, see where they should be, and lay them out on the table in the right place. And while we are at it, we just clean all the beams as well and get it ready. Let's do it.
So we've got all the pieces laid out now. We still need to do a little bit of cleaning up from all the old brims from the print. But basically the system that we're going to use is just a couple of clamps, some glue, and some activator. So we can use just some clamps to hold this together in line. After we put this glue in, it doesn't actually go off straight away. It doesn't go hard straight away. So then we can just use the activator to seal it. So one thing that we've realized is the tolerances with the 3D printer is that we get a little bit of a raised edge on each of them. So we're going to try just ripping down with the orbital sender. Hopefully that's enough just to flatten it out a little bit more. And then that should make these two line up just a little bit better. You can probably see there's a bit of a gap. It's the best that we can kind of get out of this kind of printer with the accuracy that it has. So yeah, we'll see how we go. It's probably going to be impossible to see on the camera, but on this side you can see that there's all these layer lines. And we get it nice and close to the microphone. And here it's nice and scratchy. So then on this side where we've sanded, it no longer makes that sound. So we've got it nice and smooth. It's still coarse, so the glue will still stick, hopefully. But yeah, let's get our first piece glued. Oh.
Smells right.
It's not exactly the best smelling stuff in the world.
Alright folks, we're gonna stop here for this one. It's quite a long one already. I hope you enjoyed it, and if you did, please don't forget to like and subscribe so that you don't miss out on part 2 when we're gonna show you the fully assembled 3D print, as well as preparing the mold and making the final carbon fiber piece. So yeah, that's it. I'll see you in the next one. Thank you. Bye.